guess what I did? I made one of these. It says SH up there. This is a sample and hold module from PMFoundations. And if you look at the circuit board, one thing you probably notice right away, especially if we can get this thing to focus. Hello. Yeah, maybe the best we're going to do. Here's the other side. Yeah, it's surface mount. Lots of little surface mount resistors, capacitors, other parts. One integrated circuit right in there. Yeah, I decided I was going to learn how to do surface mount soldering and make myself a nice surface mount Eurorack module. And first of all, I made this. Yeah, tiny little thing. It's got a little microprocessor. It's got, I think that's a resistor and a capacitor and a diode or something like that. Anyway, 3 parts there. It's got a switch. It's got a battery holder on the back. And when you flip the switch, you know what happens? I don't know if you can even see this, but the LED, you can see the LED lights up. You might not be able to see it's actually pulsing, kind of like a heartbeat. This is a little kit that's sold for purposes of learning how to do surface mount soldering. It's something to do for your first surface mount kit. And once you've done that, then you can do that. They're from different vendors, but that's the order in which I did things, you know. So yeah, I got the surface mount iHeart SMD kit, and I put that together, and I put the battery in and turned on the switch, and it went blink, 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 and I said, yeah, okay, fine, we're on our way. So then I started working on the sample and hold module, and it went okay. You know, it was not the world's prettiest surface mount soldering job, but it was sort of doing all right. But I had the soldering iron that was, it was new. I had just gotten it a few weeks earlier, and it started behaving a little bit funny. It just like changing temperatures on me without consulting me. And I was putting the electrolytic capacitors on and having a bit of trouble with them, and then the soldering iron crapped out completely. So I sent off an email to the soldering iron vendor and got back a reply, I think like within 24 hours, maybe less. Got back a reply that said, sorry about that, we're sending you a new one. All right, you know, no further questions asked, and no request that I send the old one back. They just sent me a new one, said, here, have this one. Okay, fine. So they got a new one in the mail, and it's been working okay ever since then. And that's good. But in the meantime, I kind of, that project was a little bit on hold, and I decided to take a break, and in about 8 months I decided to get back to it. So yeah, I finished that up in January, finished putting it together, plugged it in, turned it on, no loud bangs, no smoke, no excessive heat, and no output to speak of other than like a DC 10 volts on the output. So clearly something not going right here. So I checked what I could think of to check and didn't come up with any, didn't find anything. Got in touch with John, the guy at PMFoundations, and he said, sure, send me a picture of your board. And I sent him a picture of the board, and he replied, looks like you put the IC in backwards. Okay, yeah, I put the IC in backwards. But he immediately also took partial blame for that, because what happened was Well, I'm not sure what happened. I put that IC in back like in April. I don't know what I was thinking at the time, but it may be that I was looking carefully at the assembly instructions. And the assembly instructions have photographs, and the photograph shows the IC, and it shows the orientation of the IC, and I put my IC in the same orientation as what's shown in the photograph. And the trouble is the photographs are from an earlier version of the board, and in the new version of the board, the IC goes in the other way. And of course, it's clearly marked on the board. It just, I don't know, maybe I was looking hard at the instructions and not looking at the board, or maybe I was just off in La La Land. I don't know. Anyway, I got the IC in backwards. So John says to me, well, what you need to do is cut out that IC and solder in a new one. And you put that IC in like first for a reason, which is that you see it's surrounded by a power header and a potentiometer and a jack and an electrolytic capacitor, and all those things are much taller than the IC, and they get in the way when you're trying to solder a replacement IC in there. And I had not a whole lot of confidence that I, with my rudimentary surface mount skills, would be able to do that, but I did in fact cut out that IC, and I did in fact solder in a new one, and it all looked okay. And I plugged it in, and I turned it on, and there were no loud bangs and no smoke and nothing overheated, and there was a different DC voltage on the output, and it's still not working. So then I went back and forth with John for a couple days, on and off, exchanging messages about, well, check a voltage here, check a resistance there, and so forth. Found some dodgy solder joints that, things looked better once I cleaned them up, but it was still not working. And then found pin 9 on the IC was basically not connected to anything, or at least didn't seem to be. And at this point I was saying, okay, I think it may be time to chalk this up as a learning experience and start again with a new board, because it's not clear at all that I can fix this. And John replied to me, well, you can send me the board and I'll take a look at it. And I said, okay. So on Monday, I sent him the board, and on Thursday, early in the morning on Thursday, I got an email from him saying, I got the board, I looked at it, I touched up a couple of solder joints that looked like they could use it, and the main thing was I found that indeed pin 9 was not connected, probably because there was some damage to the solder pads, or traces when you took out the IC and replaced it. And so I soldered in. Let's see if you maybe you can even see it if we get this up close and if we get some focus. You can maybe see right in there. There's a little wire that he soldered from pin 9 to wherever it was supposed to go. And he said, now it's working. And he said, well, you happy to send it back to you? If you want to order anything from my store, I give free postage when you order from the store, and I can just throw this in with the order if you want, and then you won't have to pay postage on it. And I said to myself, okay. I spent about $15 for the PC board and panel. So I'm a $15 customer. This guy's now spent probably at least a couple of hours of his time corresponding with me and examining my board and finding my mistakes and fixing my mistakes. And he wants to send it back to me, and he doesn't want to charge me anything? How do you run a business when you spend a couple of hours supporting your $15 customers and not charging them anything? I don't know. I think he's not in it for the money. Anyway, so I said, I should order something from him just to throw some more money his way, because he deserves it. So when I picked out the sample and hold module to buy, it was kind of a toss-up between that and a ring modulator module that he also has. So yeah, I sent him an order for the ring modulator, and Saturday I got the ring modulator PC board and panel and the sample and hold board. and I put the panel on it and put it in my Eurorack and tried it out, and it indeed was working. So happy ending. Yay. Okay. I could probably assign some blame to the dodgy soldering iron. It may have been, not working quite properly before it crapped out completely. It might have had something to do with some of the bad joints. And that dodgy soldering iron, probably when I wasn't looking, it probably turned around the IC so that it was in the wrong orientation. I'm sure it wasn't my fault. But, yeah, I don't know. It also might be that some of the problems were, aside from the backwards IC, some of the problems might have been caused by the fact that this is the first time I'd used a temperature-controlled soldering iron, and I had it running at a temperature that, in retrospect and looking online, seeing what other people talk about soldering iron temperatures, I think I was running a little, maybe a lot too low. So, I'm seeing people talking about, typically using temperatures of like 350 degrees C, and I was down closer to 300, and hot enough to melt the solder, and maybe even a good temperature to use for sensitive components, but probably would have benefited from higher soldering temperatures. Anyway, lessons learned, and we'll apply that in the future. The ring modulator module is surface mount. I've got another surface mount module in the pipeline. So I'm going to continue with that and get better at it. So let's take a look here. Oh, yeah, something else you might or might not have noticed. When I went to put the potentiometers on this thing, I found that for whatever reason, I had one of, there's a 100K and there's a 1 meg, and I had one of each of the sort that fits on the board and everything like that. And the one of them has a knurled shaft, and the other one has a D shaft. And how I ended up with a knurled shaft and a D shaft potentiometer when everything else I have is round shafts, I don't know. But we'll deal with it. There's no knobs on this at the moment. I got some stuff coming in the mail soon that I hope will result in knobbiness of that particular module. Anyway, where was I? Oh yeah, it's a nicely done module. The front panel is kind of Spartan, but it, it's clear. It's good. PC board panel, I believe. And little printed circuit board. As these things go, it's not a big part count. There's like 1, 2, 3, like about 20 or so surface mount resistors, capacitors, diodes, one IC, and and the rest is through hole jacks and potentiometers and power header and one LED. Yeah, pretty simple to put together if you don't put the IC in backwards, and if you're not running your hot soldering iron about 50 degrees cooler than it ought to be, and things like that. Anyway, yeah, the assembly instructions, aside from the fact that the photographs were of a different version of the PC board, the assembly instructions I thought were pretty good, and the price was excellent. As I said, I think it was about $15 for the PC board and front panel. So yeah, it's nice. And it gives me a sample and hold module. Do you know what a sample and hold module is? Maybe you don't. It's kind of like this. How shall I put this? It's kind of like you're sitting there listening to a song on the radio, and you're singing along with a song on the radio, except that you're not really paying attention. You're only paying attention to the radio about once every 10 seconds or something like that. So once every 10 seconds, you hear what they're playing on the radio, and you sing that note. And then you spend the next 10 seconds just holding that same note. And then you notice they're playing a different note 10 seconds later. And so you go, and you you just keep doing that, and you just keep singing the note from the radio listening every 10 seconds and singing that note until 10 seconds later. That's what a sample and hold does. It does it with voltages and not radios, but that's the general idea. And it gives you some. It's a classic sort of module. Will give you some effects that I'm sure you've heard many times in electronic music. There was a sample and hold on the ARP 2600 that I started off with many years ago, and there isn't a sample and hold on the Mother 32. There are ways to get some sample and hold like behaviors out of the Mother 32, but there isn't a real sample and hold there. So it was nice having this to add to the system. So let's take a look at it. All right, let's listen. So we got a low frequency triangle wave going into the input, and the output is modulating the frequency on the VCO. So we got kind of stair step ups and down. We turn up the rate. We can change the level. Now we can also do the more classical random noise generator into the input and get a random output. They can do a mix of both. going up and down, but with random stuff on top of it. Kind of cool. Now another thing we can do is, instead of using this to modulate the frequency on the VCO, we can put this in the control voltage input on the timbre module. So that's the Sample and Hold module from PMFoundations. I've got a couple of drum modules from Barton Musical Circuits coming up soon. And as I mentioned earlier, because John at PMFoundations was so nice to me, I now have a PMFoundations ring modulator module to build. And because the folks at SynthCube were recently nice to me, I ordered another module from them. It's a Music from Outer Space voltage controlled low frequency oscillator, which is a somewhat more higher parts count, let me put it that way, surface mount kit. So I guess I'm feeling optimistic. Anyway, we've got those things coming in. There's a couple of other module ideas I've got kicking around in my head, some things to kind of breadboard and see if maybe I can come up with on my own or semi on my own. You'll hear more about those if anything develops. So definitely, do the the subscribe thing and the like thing and return and watch the upcoming videos thing and have a nice life thing. And anyway, I'll see you next time on Analog Output.